Hi, does your job involve identifying and diagnosing foundation cracks? Homeowners typically call home inspectors, contractors, and structural engineers for help. Do you have the knowledge and experience to answer these three questions? What type of crack is it? What caused the crack? And does it need to be repaired? Hi, I'm Randy with RLM & Associates. There are three basic types of foundation cracks: dry shrinkage cracks, settlement cracks, and shoving cracks. This video covers dry shrinkage cracks. Here's a short video clip showing a typical dry shrinkage crack. As you can see, a shrinkage crack is not typically straight but jagged like a lightning bolt. These cracks go completely through the foundation wall and should be the same on both sides. Before we go any further, let's look at components in a typical concrete mix. Here in this mix you can see it's 31% rock, 30% sand, 21% water, 15% cement, and 3% air. At the ready-mix plant, once the dry components are measured and placed in the truck, water is added and the components are mixed during transport to the job site. The curing process begins as soon as the water is added. Concrete cures through a chemical process called hydration. Dry shrinkage is due to the loss of a layer of absorbed water from the surface of the gel particles that hold the aggregates in place after curing. Shrinkage is defined as the decrease in volume of concrete during hardening and drying under constant temperature. If concrete shrinkage could take place without any restraint, the concrete would shrink in all three directions without cracking. In residential building foundations, as the concrete walls cures, cracks form and the concrete is restrained by the previously poured footing. Shrinkage cracks in concrete walls are typically narrow, 1/132nd to 1/1/8 of an inch wide. But keep in mind, concrete, like most construction materials, concrete contracts and expands with changes in temperature. To minimize dry shrinkage cracks and crack movement due to temperature, the ACI Guide 318 states that shrinkage and temperature reinforcement must be provided in the direction perpendicular to the main reinforcement, which are the horizontal bars in a typical foundation wall. Factors that influence the size of shrinkage cracks are outlined in the American Concrete Institute Guide AC 209. It's the guide for modeling and calculating shrinkage and creep in hardened concrete. This guide shows the average ultimate shrinkage strain to be used under standard conditions where the mix design and curing methods are unknown. The ultimate shrinkage in a wall, delta L, in inches is calculated by multiplying the wall length, L, in inches by the ultimate shrinkage factor. If information is known about the concrete mix design and how it was cured, the ultimate shrinkage strain factor can be adjusted down by multiplying by 7 factors that influence crack development. Equation 1 factors in the number of wet cured days. Equation 2 factors in the ambient relative humidity the concrete is exposed to after curing. Equation 3 factors in the volume to surface ratio. Equation 4 factors in the slump. Equation 5 factors in the percent of fine aggregate in the mix. Equation 6 factors in the cement content. And equation 7 factors in the percent of air in the mix. 2 of these factors, the slump and the relative humidity after the initial curing process, are greatly influenced by the contractor's operations on the job site. Adding water to the mix at the job site increases slump, which increases the shrinkage. Exposing the concrete to hot, dry, windy conditions increases evaporation, which increases the shrinkage. Typically, though, anyone looking at shrinkage cracks will not have any prior knowledge of the concrete mixture or curing process. In this case, the default shrinkage strain factor is used. For example, if you have a 50-foot concrete wall, you could estimate the maximum expected shrinkage over the length of the wall by multiplying the wall length in inches by the ultimate strain factor 0.000780, which equates to 0.468 inches of total strain. If you need specific information about the concrete mix design and how it was cured, then using some or all of the 7 equations from the ACI guide, your ultimate shrinkage strain factor could be significantly reduced. In residential foundation of uniform height without wall openings, you can expect shrinkage cracks to be uniformly spaced. Uniform crack spacing and width does not apply when the foundation wall contains openings or changes in height. Based on experience and engineering stress analysis, this graphic shows areas where shrinkage stresses cause cracks to occur in predictable locations. These predictable areas are due to stress concentrations where the wall cross-section has been reduced due to openings or changes in the wall height. Once the foundation wall is severed by the first shrinkage crack, essentially you have two independent wall sections. This process continues on each independent wall section until the dry shrinkage stress is reduced below the tension capacity of the concrete. This process may result in some cracks being wider than others. Now that you have knowledge on how to identify shrinkage cracks and how they form, the question every homeowner wants to know is, do they need to be repaired? If they're not leaking into the basement or crawl space, do nothing is an option since they're only cosmetic at this point. If they leak, you should try and prevent the water from corroding the steel in the wall. The cheapest option is to minimize the amount of water next to the crack by improving surface grading along with better gutter maintenance. If grading and gutter maintenance alone isn't enough, then some type of crack repair method such as epoxy injection or polymer injection from the inside may work. If not, the next option, which is the most expensive, would be to expose and repair the crack from the outside, then waterproof the exterior foundation wall. Most modern foundations have a black asphaltic dam-proofing material applied on the exterior of the foundation wall prior to placing the backfill material. In areas with high water table or other severe soil water conditions are known to exist, waterproofing is required in the International Residential Code. There is a distinct difference between damp proofing and waterproofing. Damp proofing is intended to keep out soil moisture, while waterproofing keeps out both moisture and liquid water. Effective foundation waterproofing is more than just one product. It's a system with three critical components: a waterproof membrane to protect the concrete, a drainage mat to relieve hydrostatic pressure and allows water to drain down, and an aggregate covered pipe drain at the footing level to carry water to daylight or to the sump pump. Hi, you should now have the knowledge to identify a shrinkage crack, explain what causes a dry shrinkage crack, and you should be able to give your client some options for repairs. Important note, the next time you talk to a client about dry shrinkage cracks, I recommend you suggest they monitor these cracks on an annual or semi-annual basis. This is important because other foundation issues such as settlement and horizontal shoving can cause a common shrinkage crack to open up. Hi, I hope you found this video useful. Thanks for watching.